connection here with this fundamental theorem of the calculus. Okay, so yeah, if I want to do that one, you could probably guess, if I did that one the long definition way, I would probably wind up using the sum of the I cubes formula at some point. You'd have to do a little bit of work to get there, about as much, a little bit more probably than the one with the x squared. But anyway, we don't have to do that. Now all we have to do is this the antiderivative, right? I know that, so it'd be the antiderivative evaluated at 3 minus the antiderivative evaluated at 1. Well, let's do it this way first, I guess. If this is f of x, then the antiderivative would be 1/4 x to the 4th, right? So it'd be 1/4 of 3 to the 4th minus 1/4 times 1 to the 4th, which is 81/4 minus 1/4, which is 20. I did all that right. Okay. One page, and you get 20. So it is, it's almost too easy sometimes. Think about it. Because when when we did the derivative rule, we came up with that power rule. That was almost too easy, wasn't it? Because instead of having to go through the limit of the secant lines, you just go right to the power rule and you got it. Well, it's the same sort of thing here. Your antiderivative is what you're going to do. Now, just a little bit about notation. Usually the way you might see this, if let me do it this way. Just do it in general here. A lot of times this is more how, instead of having to write that, because we'll get longer and longer, of course, problems, because now we can do just about as complicated as we want. This is kind of a shortened notation, if you will. It means the same thing. It just says get your antiderivative and then throw in your upper and lower limits. You can keep those indicated over there. All right, so a couple of quick things. Yeah, we know an antiderivative here, this is not going to change anything. I could still just do the antiderivative. It would be, what, 8 over 6, x to the 6 would be the antiderivative. I'm going to evaluate it from 0 to 4. That reduces to be 4/3, so it would be 4/3 x to the 6 evaluated from 0 to 4. Of course, what that means is I'd have 4/3 of 4 to the 6th minus 4/3 times 0 to the 6th. Upper limit minus your lower limit. Just plug in x to be 4 on those. And that winds up being 16,384 divided by 3 minus 0, of course, so 16,384 divided by 3. Okay? What if, and this is where those properties really come in handy, what if we do the integral from -1 to 3 of x cubed minus 5x plus 7 dx? Well, that's still just a polynomial, so the antiderivative is really fairly easy. Like we said, the integral, if you've got subtraction, you just do the antiderivative of each one. So it'd be 1/4 x to the 4th minus 5 halves x squared plus 7x, wouldn't it? From -1 to 3. Yeah, just your antiderivative. Okay. Now the reason I'm not writing C here is because we said we wanted, back on that original paper, the handout, I said let's choose C to be 0. Why did I do that? It's because even if I chose C here to be C, okay, if you think about it, when I go, let's do it down here. If I do plus C here, what's going to happen? I have plus C here, and then I've got minus C here, don't I? Aren't those going to cancel? They cancel out because you got a plus C and you got a minus C, whatever you choose C to be. So why not choose it to be 0? We do. You won't always get away with that, but on this case, when you're doing, now, we'll talk about where we have to add a plus C next time, but for now, we don't have to even do a plus C because the plus C's are going to cancel. I'm going to do this minus that. Now, what I've got here, I'm actually out of time, but 1/4 times 3 to the 4th, which is 81, minus 5 halves times 3 squared, which is 9, plus 7 times 3, which is 21. Minus, now, be careful with the second one because we are doing minus this one. That's going to change all these signs. You're going to have 1/4 times -1 to the 4th minus 5 halves times -1 squared plus 7 times -1. But all those being behind the minus, let's say that'd be 81/4 minus 45 halves plus 21 minus, that would be 1/4 minus 5 halves minus 7. So I guess there's different ways, but if we do just keep those signs, yeah, all those signs changes because you got to distribute the minus. Be careful with that. But other than that, it's pretty well straightforward.
Can you go back to the bottom here for a second? Where did you get the plus and the minus C?
If we chose the antiderivative to be plus C instead of saying 0, say it was, officially the antiderivative is saying this plus C, right? So if I put that plus C in there, it's just going to cancel out. So that was just to answer his question. So don't let that. Just choose C to be 0.